Hi friends, today we will be discussing modulus function, its basics, graph and transformation of modulus functions. Modulus function is also known as absolute value function, and but it's as per the definition of modulus function, y is equal to, if y is equal to modulus of x, then it is equal to x if x is greater than equal to 0, and minus x if x is less than equal to 0. So this is the definition of modulus x. Now some basic properties about modulus function. That what actually is a modulus function? It is the value of x without the sign. So if it is minus 3.5, it is the value of modulus of x would be 3.5. So it is just numerical value of. A very important property of modulus function is that it is symmetric about the x and y axis. Now, as you can see, this is the graph of modulus function when x is positive, and this is the graph of modulus function when x is negative, and these two parts are the mirror images of each other. As is obvious from the graph of modulus of x, the domain of this function is the whole the range of real numbers, and similarly the range of this function is all the positive numbers. As this graph is above x-axis, no value is below x-axis, so y is not negative. So the range of this function is only the positive values of y. So this can be, the domain can and range can be represented in the following manner. Now let us discuss some properties of modulus functions. Suppose modulus of x is given as less than equal to a, then x would be between minus a and a. Similarly, if modulus of x is greater than equal to a, then x would either be less than equal to a, or x would be greater than equal to a, but it would not be between minus a to a. Now the next property, that is modulus of x plus minus y will always be less than equal to modulus of x plus modulus of y, and it would always be greater than modulus of x minus modulus of y. See, if we don't use this modulus sign, this modulus of sign, then modulus of x minus modulus of y as such may be negative. If absolute value of x is less than y, then in any case this would be modulus of anything would be greater than value this negative value. So the most important thing to note and remember is this particular modulus sign, that modulus of x plus minus y would always be greater than equal to modulus of x minus modulus of. Now let us discuss transformation of modulus of x under various conditions. The first case we will be considering is transformation of graph of modulus x to modulus of x plus minus a. This is a very simple example, but it would be used in many problems. So now for example, we will be plotting the graph of y is equal to x plus modulus of x plus 2 and y is equal to modulus of x minus 2 with the help of y is equal to modulus of x. So in the first instance, we will be plotting the graph of y is equal to modulus of x plus 2. Now the point to remember in this case is that this is essentially a case of shift along y axis. This can be written as y minus 2 is equal to modulus of x. Now So we are moving y to y minus 2. Now since it is a movement along y axis and x axis remains totally unchanged, so what we can say that every point with on y axis will be moved 2 units. Now it would be moved 2 units upwards or downwards. Now to check that, what we have to see is that if we put x is equal to 0 in this equation, y becomes 2. So now the origin has moved to 0, 2. So it has moved upward, which is obvious from this diagram. So every point has moved 2 units upward. So whenever it is y minus 2, it moves upwards. But I would suggest students don't try to forcibly remember this thing, that when it is y minus 2, they should move the graph upwards, and when it is y plus 2, they should move the graph downwards. Because if you try to memorize these rules, then the problem is that in the exams, by the time this chapter is over, there would be 20 such rules and you would be confused in the end. So the only way I suggest to memorize something is either by repetition. If you repeat something, then you automatically remember it. The second way is that you empirically derive the formula in next 4 or 5 problems when you are shifting, and the very good way to remember is from the graph of y is equal to modulus of x. So you just close your eyes and see y minus 2 is equal to modulus of x. So in this case, x, if we put x is equal to 0, we get y is equal to 2. So we are moving upwards. So whenever the y is changed to y minus 2, we will be moving the graph upwards, and whenever it is y is plus 2, then we will be moving the graph downwards. Now let us consider transformation along the x-axis. So in this case, these are the cases. Now here the original graph is y is equal to modulus of x, and now we are shifting it to modulus of x plus minus a. So we will be again considering following two cases: y is equal to modulus of x getting transformed to y is equal to x minus 2, and y is equal to modulus of x plus 2. Now the main thing again would be, we know that in this case the graph would be shifted along x-axis, but whether in which case it would be shifted to right side and in which case it would be shifted to the left, that is the important thing and thing to remember. Now as we are seeing from this graph that in case of y is equal to shifting of y is equal to modulus of x to y is equal to modulus of x minus 2, the graph is shifted towards the right. So as was the case when we shifted y to y minus 2, it was shifted upwards. So in the case of x to x minus 2, it is getting shifted towards the right. Now as is shown in this image, that this was the original graph and this is the new graph. So it has shifted towards the right. Now, the easier way to remember is not that, okay, whenever x is going to x minus 2, we will move it to the right. But initially for 3-4 problems, try to do it empirically. Like if we put x is equal to, if we put y is equal to 0 in this graph, we get the value of x is equal to 2. So it means the graph has, the origin has shifted from 0, 0 to 2, 0. So the graph has moved towards the right. So this I would suggest is the better way to remember. Now as is clear from this graph that y is equal to modulus of x has shifted to y is equal, when it is shifted to y is equal to x modulus of x plus 2, then it has moved to the left side. Now this is the new graph of y is equal to x plus 2. Now let us consider another transformation of modulus of x to modulus of ax. Now let us consider the example of transformation of y is equal to modulus of x to modulus of 2x. So modulus of, see in this image, although it is not mentioned in the image, but it is obvious this we will, as per our convention, we will be using the red line for the initial graph and green line for the transformed graph. Now here this is the graph of y is equal to x and this is the graph of y is equal to 2x. Now what has happened when we have transformed it to x to 2x? The graph has shrunk along the y-axis. So earlier the graph's width was this much and now the graph's width has become this much. Why has it become this much? That earlier for say y is equal to 1 the value of x was 1. Now for x is equal to half only the value of y has become 1. Again, like I mentioned in the last case, that we would not remember that in which case it would be shrunk and in which case it would be expanded. Now it is obvious that in case of y is equal to modulus of x by 2, the graph would be something like this. So it would be expanding. But to remember it, let us remember with this example only that in the first case, rather than at x is equal to 1, at x is equal to half only, the value of y would become 1. So the graph would be shrunk in the first case and it would be expanded in the second. As this is an important topic, we would take another example of this kind of transformation. And this is the graph of this original graph. This is the graph of y is equal to sine x, and this is the graph of y is equal to sine 2x. So as we saw in the last example, when we transformed x to 2x, the graph shrunk. Here also it is the reason I am showing you this graph, that this shrunkenness is more apparent in the case of graph of sine x. Like it is very clear that this graph has shrunk like this. And now in this case, at x is equal to pi by 4 only, the value of y would become 1. So from x is equal to pi by 2 to x is equal to pi by 4 only, the y will attain its maximum value. So now let us consider another example. This is the graph of y is equal to sine inverse x, and we are seeing how it will transform to the graph of y is equal to sine inverse 2x. Now again the graph has shrunken and it is very apparent that initially at 1 the value of y was pi by 2, now only at half the value of y becomes pi by 2. So I think with the help of these three examples, you will kind of pictorially remember that when we transform x to 2x or 3x, it shrinks, and when we transform x to x by 2, x by 3, then it would expand. Now another example. We are considering the example of y is equal to 1 by 2 sine x. Now when we transform the graph of y is equal to sine x to y is equal to 1 by 2 sine x, it is essentially a transformation along the y-axis. It is transformation of y to 2y. Earlier we did the transformation of x to x 2x or x by 2, but now in this case we are transforming along the y-axis and we are transferring from y to 2y. So in this case we are seeing clearly, like in the earlier case when we changed x to 2x, y had the graph had shrunk along the x-axis. Similarly in this case also, the maximum value of y would become y is equal to half. So the graph shrinks along the y-axis. So in both x and y-axis, in both the cases of x and y, when we transform the graph from x to 2x and y to 2y, the graph shrinks along the x-axis and y-axis respectively. And now the next case of transformation is from y is equal to fx to y is equal to minus fx. So if fx is equal to modulus of x, then we will be considering the graph or the transformation of graph of modulus of x to minus modulus of x. Now this is the graph of modulus of x. When we put a negative sign, then what would be the value of y, say at this particular point, at y is equal to 1. The value of earlier the value was 1, but now it will become minus 1. And when say it is 2, then it would become minus 2. When it is when the value was minus 1, then when the value of x was minus 1, so the value of y still was 1, but the value of minus of modulus of y would become minus 1. So in this case, this graph would be the mirror image of the original graph along the x-axis. Now here the point to remember is that when we transform the graph of fx to minus of fx, then it is the mirror image along the x-axis, and when we transform the graph of fx to f minus of x, which we will discuss with another example, then it would be the mirror image along the y-axis. Now rather than remembering, if you just keep this graph in mind and say that okay, now whenever in this case all the values were positive and now the value of y has become negative, so we will be taking the mirror image along the x-axis, then it is easier to remember. Now another example of the same kind of transformation from fx to minus fx. Now in this case, let us take the example of y is equal to e to the power x and transform it to y is equal to e to the power minus e to the power x. So in this case, what has happened, that this was the original graph, and now comes the question whether we have to take the image along the x-axis or y-axis. So we just say that okay, when x is equal to 0, when x was 0, y is equal to 1, and in this case when x is equal to 0, so it is minus 1. So the graph would be transported in this way, and the image would be along the x-axis. So here we are again not trying to just say that okay, take the mirror image along the x-axis, because that is something which we are bound to forget or confuse. So let us always try to do a few problems empirically, and then the issue would be cemented in our mind, and in case we ever get confused, we will again do it in this way, that we will take a, even if we are given a very complex graph and we are in the middle of graph and we have to transform the value of fx to minus of fx, then just take a simple graph, say of modulus of x, and remember its image and how we had transformed it, and we would recall that we had taken the mirror image along the x-axis in this case. Now let us take the example of transformation from fx to f minus x. Earlier case we had transformed the graph of y is equal to e to the power x to y is equal to minus e to the power x, and had taken the mirror image along the x-axis. But in this case we are considering the graph of y is equal to e to the power x and transforming it to y is equal to e to the power minus x. So as is clear, this is the graph of y is equal to e to the power x. Now what would be the graph of y is equal to e to the power minus x? That in this case, when x tends towards infinity, y tends to 0, y tends to infinity, and in this case when x tends to infinity, here, then y tends to 0. So what is happening, and when y is equal to e to the power say 2, then this is and the value is say somewhere here, then in this case what is the value, y is equal to e to the power 1 by minus 2, that is y is equal to 1 upon e square, which is the mirror image of a particular point along the y-axis. So, in this case, the graph of y is equal to e to the power x. When we transform it to y is equal to e to the power minus x, we take the mirror image along the y-axis. We will consider another example from which it would become more apparent. Now, in this case, the graph, this is the graph of a general function which is like this and like this, and when we transform and another case we are considering when the graph is like this, then what would be the value of the graph of y is equal to minus f minus x. So in this case, when we are transferring fx to f minus x, let us draw the graph of fx. So how is this transformation done? Suppose this is the value of, this is x is equal to 1 and this is the value of y is equal to f1. Then what would be the value of f in case of f graph of f minus x? See, the absolute value would remain same, but it would be for minus 1. So earlier if this was the value f1, then this would become the value of f minus 1. So what happens that this is, if we do it for large number of points, we would see that this is nothing but the mirror image of y is equal to x fx graph along the y-axis, because whatever this distance is same as this distance is same as this distance, and similarly this distance is same as this distance, and this distance is same as this distance. So what is happening that in the transform graph, the value of y is equal to f2 would become the value of y is equal to f minus 2. So this is the graph now. This point and this mirror image is even more clearer from this image, that this is the y is equal to fx graph. Then the mirror image of this line is this, mirror image of this line is this, and for the lower portion when x is equal to negative, it gets transformed here. So with the help of these two examples, I hope that you have clearly understood these two transformations. Now let us consider the graph of y is equal to modulus of x. We had initially drawn that graph from the definition of y is equal to modulus of x. But this time we will try to draw the graph of y is equal to modulus of x from the graph of y is equal to x. Now, so this is the graph of y is equal to x. Now, the thing is that when we draw the graph of y is equal to modulus of x, then the negative for negative values of x, that is this portion, when the value of x is negative, then for those values of x also the value of y would be positive. So we ignore this portion, and this portion would become the mirror image of the graph of y is equal to x when the x was positive. So finally we get the graph of y is equal to modulus of x from the graph of y is equal to fx. Please recall that we had drawn the graph of y is equal to f minus x from the graph of y is equal to fx. So in that case, what we had done, whatever were the values of x, we had transferred them to the value of what the value was for minus x, and whatever was the value of minus x, we had transferred them to values of fx. So in that case, for the whole values, for all the values of x, we had taken the mirror image of the graph along the y-axis. But in case of y is equal to modulus of x, the values of y, when x is positive, the graph would remain same. It would not be transferred along the graph of y is equal on the transferred by taking its mirror image along the y-axis. It is only when this graph, when the value of x is negative, that is in this region, then the value would be transferred, this graph would be transferred from here to here by taking its mirror image. So this becomes the graph of our y is equal to modulus of x. Now let me try to explain it from another example. Now this is the graph of y is equal to x square minus 2x minus 3. Now we have to transform this graph from y is equal to x square minus 2x minus 3 to y is equal to modulus of x square minus 2 modulus of x 3. Now this is a case of transformation from f(x) to f modulus of x. Wherever we had x in this, we had transferred it to modulus of x. The graph of y is equal to, here it should be negative, so it should be y is equal to x square minus 2x minus 3. Now how to draw this graph? See, this is a classic upward facing parabola because it is of the type of x square is equal to 4ay. Now in this graph, the minimum would occur when the two roots of this graph are equal, when we put y is equal to 0. So this value would be minus b upon 2a, which in this case would be 1. Minus 2 upon 2, because a is 1. So for this particular quadratic equation, the minimum would occur at x is equal to 1. When we put this value, we will get the value of y is equal to y as value of y as minus 4. And when we say that for what values of y, for the y is equal to 0, what are the values of x? So we will get minus 1 and 3, which will give us these 2 points. And we know the shape is parabola, so we smoothly draw the graph of y is equal to x square minus 2x minus 3. Now, as was done in the earlier example, when we drew the graph of y is equal to modulus of x from the graph of y is equal to x. So here also, in this case, what we would do, that this portion of the graph, now this portion of the graph is the portion when the value of x is negative. So as is clear from this image, which is the final transformed image, this negative portion of the graph, when the value of x is negative, this would be ignored, and we will be taking the mirror image of the remaining portion from along the y-axis. So the final graph would become this. So there are two steps when we transform fx to f modulus of x. First, we ignore the portion for which the value of x is negative, that is this portion. And second part is that we take the mirror image of the portion in for which the values of x are positive, and this becomes the remaining part of the graph when x is equal to negative. Now let us consider the transformation of fx to modulus of fx. Let us take a generic graph. Now we have chosen this particular graph because when we transform this graph to modulus of fx, we will have all the properties explained properly. So there are two steps for this graph. The simple and easy method is to tell you that ignore this portion and then this portion, and the portion of which shows the values of phi below the x-axis, ignore that portion and take a mirror image of this portion along using x-axis as the mirror. So this position becomes this position, and this position becomes this position, and the position above x-axis remains same. This position remains same. But now comes the questions why we have done it, as has been our emphasis throughout this lecture, that we don't want you to remember any of these transformations. We want you to understand and then remember these transformations. So what is happening when we are transforming y is equal to fx to y is equal to modulus of x? Now have a look at this function. Now in this case, y, when we are taking modulus of fx, can y be negative? No. So y has to be always positive. So therefore we have to ignore all the values which are below the x-axis. So we are left with only this portion of the graph which we are shown here. Now what we have to do is, what is the value of y is equal to modulus of x? It can be represented as y is equal to modulus of x and modulus of fx when fx is greater than 0, and it will be y would be equal to minus fx when fx is less than 0, as per the definition of mod x which we studied in the first slide of this lecture. So for all those values of fx, when fx is negative, that is this part, y would be equal to minus fx. Now it is obvious that for this particular portion, the value of y would be the mirror image. Now we don't need to remember anything, and the transformation of this graph to this graph is logically understood. That is, the portion of y which is below x-axis has to be ignored because value of y cannot be negative. So the graph of y has to be above the x-axis. So and the portion, the value of y would be fx if the fx is positive. So this portion remains same, and this, for when the value of fx is negative, value of y becomes minus fx. So this point gets transformed to this point gets to point transformed here, and we get the transformed graph's value like this. So here is the final graph, which is above the y-axis because modulus of fx cannot be negative, and these portions are the mirror images of the negative portion when the value of y is negative. Now we are coming to end of journey as far as this lecture is concerned, and we are going to consider the last transformation, that would be transformation of y is equal to fx to modulus of y is equal to fx. I hope you will not get confused with this transformation and other transformation, because we have gone empirically with each transformation. We have not just told you that cut this portion, take mirror image of this portion, shift this portion here and that portion. We have tried to logically tell you all the transformations so that you don't have to remember anything. Now in this case, what happens that when we are saying that we have to draw the graph of modulus of y is equal to fx, then can fx be negative? So no, it cannot be, because it has to be equal to a modulus value. So modulus of y has to be positive. Now this is the first condition. Now if this is the graph of y is equal to fx, then in that case the values below x-axis, as was the case in the last one, we have to ignore these values. Now in case of y is equal to modulus of fx, what we had done, after ignoring this portion of the graph, we had taken mirror image of this portion and like this, and this was the final graph for y is equal to modulus of fx. So first part is same in both the cases, that we have to ignore that portion of the graph where the value of fx is negative, because in this case also since modulus of y cannot be negative, so we have to ignore this portion of the graph. Now we are left with this portion of graph only. Now suppose modulus of y is equal to 1 here. So what does it mean? That modulus of y is equal to means that y is equal to plus minus 1. So for each value, the value of modulus of y would be 2, because so we will have the mirror image of this portion of graph as well here. So the final graph would be this portion as well as this portion. So both these portions will coexist in the graph. So far what we have been doing, that whenever we were taking the mirror image of earlier graph, we were ignoring the line whose image we had taken. But in this case, we will be having both the images in the final answer, because modulus of y is equal to 2 would mean y is equal to modulus y is equal to plus minus 2. तो हमारी जो y की वैल्यूज है वो दोनों रहेंगी, प्लस fx as well as minus fx. So the final graph would be this and this portion. So with this we complete this lecture on transformation, especially with reference to modulus function. In next couple of lectures we will be discussing the transformation of bracket x function, that is that would be a greatest integer function, and then middle bracket x, which would be the fractional part of the value of x. So we will be there, but before we move to those graphs, in the next lecture itself we will be doing some good number of examples. So, and even in those examples we would be handling all the cases empirically, right? Not just telling you that okay, now move it to 2 units to the right or 2 units to the left and ignore this portion on that portion. We will try to tell you all those 3 steps empirically, so that you don't have to remember. Now just imagine we have covered dozen odd steps even in this set of transformation only. Then what would happen when we go to bracket x, that is greatest integer function? So we cannot just remember all those cases, and it is not advisable even if you have very good memory. Some things you will remember because if you practice more, you will be remembering those things. But just after doing, there is no point to try to remember from the first understanding of the explanation itself. In the first, when we are explaining to you, you don't have to load your mind by trying to remember, but just try to understand. You will remember when we do more examples. Apart from this video, you will have all the details of this lecture in the form of notes at Exxamm.com/12373. Now that 12373 is the lecture number, and Exxamm.com, where the spelling is EXXAMM.com/12373. So you can get the whole this video, this lecture, and the link to next lecture at this URL. Thank you for listening to us patiently. X.